Now let us look at exercise 5. So here is again some real solution that I actually got from students. So let me explain what the issues are here. Well, there are some comments here, but these comments are actually all right because this comment explains what's going on in the code rather than provides a general intuition for the solution of this problem. So this are okay. So what is not okay is this part. Right? So notice that here the explanation that is required here. So the explanation of why a real network has high clustering coefficient and a skewed vertex degree distribution as opposed to an Erdős-Renyi random graph. So this explanation, instead of being typed in a markdown cell, it is printed by a Python comment. So of course it doesn't really make much sense to do it. So I'm going to delete it. So to fix this, I'm going to delete it, and I'm going to insert a markdown cell. Sorry, markdown cell, and I'm going to delete the print part. So, and then there are some issues. So like this is really P should be an equation, the clustering coefficient G should be an equation, is much higher, and so on and so forth. So now this is, at least it looks all right. The edges in the Erdős-Renyi random network are even okay. So let me go through other issues. So the next issue here is that there is a for loop that is absolutely unnecessary, right? So notice that the same thing can be achieved by the comment S1 is np.sum a1 axis 0. So nothing has changed. Right, so what I want to say is that very often, well, when you need to do some simple operation, like here it's the, you are taking the sum of all rows of a given matrix or all columns of a given matrix. So this operation, most likely it has been programmed into numpy and is already there. And here, if you just read the manual on the comment np.sum, then you would have known it, right? So that's the second takeaway. So the first is human language goes to markdown cells. Second is simple operations are very often already exist in numpy or networkx functions. And the third one is, of course, is that this is not really a full explanation. So I would probably write something more comprehensive. So the edges in the Erdős-Renyi random network are evenly distributed with probability p. What does it even mean? Whereas the clustering coefficient of G is much higher. So this is the true observation. So that the clustering coefficient of G is much higher than the that of the Erdős-Renyi model. That's true. But I was looking for an explanation of why this is so, and I was looking for another explanation of why the vertex degree distribution in the real network is highly skewed, while in the Erdős-Renyi model it is more or less centralized around the mean. It is a binomial distribution, right? So again, please try to do a better job when you are explaining things. So our course is not just about coding, but also about understanding and interpreting real life phenomena. So you need to put some effort into explaining stuff.